Also at this point they have no idea where the angle of incidence is and the angle of refraction. So let's get into the experiment to give you a better idea. Hi parents, in this part of the video what I'll be showing you is how light is affected by different optical mediums. So this is where refractive index comes into play. Now at this point you can see that the angle of incidence is 0, so the light travels straight through. But as I turn this object counterclockwise, you will notice that now the light is no longer going in a straight line. So instead of going this way, it has gone from here, bended, and then went in this direction. Now for the refractive index bit, what you need to remember is this, that here, if I want to calculate refractive index here, I will take the normal. The normal is basically a line that is perpendicular to the surface. So I'll take the normal, and this is the incident ray. So this is the angle of incidence here. Whereas the normal and the refracted ray, that's the angle of refraction. So when I want to calculate the refractive index, I'll take n equals to sine I over sine r. But at this point, it's slightly different. Again, you have the normal. This is your angle of incidence and angle of refraction here in the normal. Here, I won't take n equals sine I over sine r. Instead, I will take it as n equals sine r over sine I. So that's the big difference. So please tell that to your child because this can make a difference in their marks. This is where a lot of students actually make the mistake. Okay, one very big PSA I will have to do is number one, do not do TYS for the sake of it. Parents actually come to me and they say that, you know what, I need to get a kid to do TYS, but TYS is not exactly the best situation before the prelims. Yeah, you can do the TYS maybe nearer to the exams. Okay, one very big PSA I will have to do is number one, do not do TYS for the sake of it. Parents actually come to me and they say that, you know what, I need to get a kid to do TYS, but TYS is not exactly the best situation before the prelims. Yeah, you can do the TYS maybe nearer to the exams, like the O levels, but not right before the prelims, not right before the media. Other than that, also memorizing school notes is a definite no-no. I mean, when it comes to physics and chemistry, it is not just memory. It's not about defining moment or defining work done. You need to know how to apply your concepts. And that's where it's very important to actually get your child to have targeted practice. And that's what we do in at Ministry of Science. We actually have a database of questions to help your child to be able to answer questions that will be tested, and that's what we want. We don't want them to do questions that will not be tested and they're wasting their time. All right. Welcome, guys. For those who are here, thank you for joining us. Now, if you have any friends who you think will benefit from this Facebook Live, do get them to join in also. I think it'd be very useful for them too. A few other things to just run through on you guys. What we'll be doing is we'll be talking about the moments, energy, and pressure. So if you have friends that are struggling with these topics, do get them to join. The person who's watching, remember to share this on your page so that other people can also join in. Because again, at the end of it, for the Kahoot quiz, we can only do a Kahoot quiz if there's a minimum of 3 people. All right, let's go into this. Feel free to ask any questions related to the topic. And if let's say you have anything that you're not too sure, just clarify, put in the questions. Now, for moments, let me just run through a very basic concept of moments. Basic concept of moments is just this. Let's say you got F1 and F2, right? And this is D1 and D2. Now, what will happen is here is clockwise moments, here's anti-clockwise. So this is what you call the rotational equilibrium. So sum of clockwise equals sum of anti-clockwise. So this is what we call rotational equilibrium. Usually with this, most of your questions you should be able to solve. But keep in mind, if you want to find the force at the pivot, you can't exactly use rotational equilibrium. So what you do is you actually use this thing called translational equilibrium. And translational equilibrium just means sum of upward equals the sum of downward. So just take note of that. Sum of upward equals sum of downward. Now, let's say for this question, so what I want you guys to do is this. If as you are reading it, you already got a rough idea, just go ahead, put your answers in the chat. I'll love to answer them. Yeah. If the toy is tilted slightly, it does not topple but return to the original position. Take note, this is talking about stable equilibrium. If it returns back to the original position, we are talking about stable. This is because, and for stable equilibrium, you must remember that your center of gravity is always below the pivot. So just take note that if let's say pivot is here, center of gravity is here, it's stable. If you have your center of gravity above and your pivot is here above, that is unstable. But if your pivot and your center of gravity is the same point, it's neutral. So in this question, just take note the answer is below the pivot. Yeah, so answer is C. Now, for this, the stability of a bus is tested by tilting it on a ramp. The diagram below shows a bus that is just about to topple over. When you say just about to topple over, it wouldn't be D because it is very stable. If about to topple over, it will be at this pivot point. So I'll go with the answer C. For B and A, right, it's outside of the base area, so definitely will topple over. So just take note of that, and that's very, very important. Because what a lot of students I find them doing is that they make that mistake where they think that it will be the one between the both tires, but it has to be at the corner of the tire. That is what makes it about to topple over. Now, if you look at this question, a 2 kg uniform meter rule, pivoted at meter rule just means 100 cm. Now, if you look at the pivot, it's at 40. So that means your ruler, the 20 newtons, is actually at the 50 cm mark. So these are things that you can read from the question and then you figure out. So to balance the meter rule horizontally, a third mass is placed. What is the suitable mass? Take note, this is 20 newtons, this is 50 newtons. Sum of clockwise is 20 times 10 plus 20 times 10 plus 20 times 50. And what you will get is 200 plus 1,000. So it's 1,200 Newton cm. Sum of anti-clockwise is, if you take 50 times 40, is 50 times 40, I think will be 2,000 Newton cm. Now you can see that the difference is that you need something that is clockwise. That means it should be on the right side, and it should contribute to 800 Newton cm. So anything that is 30 and 20 is out because we want it to be on the right side. So if I consider 60, right, 60 cm, and it is 3, so 30 newtons. 30 times 20 is 600, but I need a difference of 800. So if I take 2 kg at 80 cm, so 20 newtons, 80 to 40 is 40, 40 times 20 is 800. So you know that's how you can identify that the answer is A. Just take note on that, yeah? Now for this, four hollow pipes, P, Q, R, and S have one or two weights attached to their inner surface as shown in the diagram. Which hollow pipes are in the state of unstable equilibrium? Now take note that if you say it's unstable equilibrium, we are looking for something where it will fall over. That means that pivot for this is more or less in the center. If you have two objects here, that means your center of gravity is above the pivot. So that means it will topple over easily. So I'll go with the answer, most probably Q. Q is highly likely. P also likely. So I'll go P and Q. The idea of unstable equilibrium, very simply put, is this, that you always want the center of gravity to be above the pivot point. So just take note on that. Now, informed ladder rests in equilibrium against the rough surfaces of wall and floor. Which of the following free body diagrams represents the forces acting on the ladder is correct. Now, you must remember that reaction force is always vertically above. Yeah, vertically above. Because they say rough surfaces of the wall and floor, if it's going to fall, it will slide towards the left. And if it slides towards the left, your friction force here will be to the right, friction force here will be up. So you're looking for anything that gives you those type of values. So I will go with the answer D. D will make the most sense. Yeah, because it literally follows everything that I've mentioned. Okay. Now, the diagram, if you look at this, right, the diagram shows three forces of magnitude 14, 16, and 30. Which of the following statements regarding resultant moment and resultant force are correct? Now, in this type of cases, right, what you have to do is you consider your clockwise first. Let's say I call this R, R, and R. So this will be 16 times R. This will be 14 times R. So that will be 30R. But your sum of your anti-clockwise will be 30R. So actually the moment, right, will be 0. Resultant moment will actually be 0, because they will cancel each other out. But your forces definitely non-zero, because here you got in this direction, but towards the left you don't have anything that's opposing these two. So that's how you tell that the answer is delta. Simple as that. Yeah. Now for energy, so I will run through real quick on how do you actually go about solving energy type of questions. Energy type of question, just remember very simply you take is kinetic energy is half mv square. GPE is mgh. Work done is force times distance and parallel distance. Efficiency is useful energy over energy input times 100%. And then you have your power. So power is always work done over time. So just take note on the different portions, and very important to consider this, the general formulas that you will do. Now, let's go into the first question that may come out, or you all may see. A 5 Newton force exerted on object R along a rough surface of 10 meters. What's the gain in kinetic if the force of friction is 2? So you have to ask yourself, okay, this topic, right? One thing very important, or one thing I've always noticed is this, that you do have to consider work done by what? So what's providing energy? So work done by F. What's taking energy is work done against friction plus gain in Ke. Now, once you got this, I got the 5 Newton that is exerted on 10 meters. So this will be 5 times 10, which is 50. Work done against friction is 2 times 10 plus gain in Ke. So if this is 50, this is 20, right? Gain in Ke is just 50 minus 20, 30 joules. Yeah, so just take note on this. The answer is C. It's as simple as that. So all you need to take note of is you are basically taking the difference in the energy. You take one minus the other. And the framework, very, very, very important. Now, a bullet of mass 0.02 kg moving at 300 strikes a fixed wooden block of thickness 0.025, images with a speed of 200. So you have to ask yourself, okay, for those who are here, right, can you tell me what is the convert, or what is being lost? What energy is being lost? What do you all think is the energy that is being lost? Then I can give you all a better idea on what might happen. Stargaze, thank you for the like. Yeah, the rest of you, what you can do is, what do you think is being lost in terms of energy? So I'll write what is gain. Gain will be work done against friction. It will be work done against the friction of the block. So just take note on this part. Now here I'll say loss in Ke. Loss in Ke, work done against friction. So in this case, right, what will happen is that I will take half bracket your mass 0.020, 300, work done against friction will be force of friction times 0.025. Your loss in Ke is half times 0.020, 300 square minus 200 square. And then you just calculate. So in that case, what I'll do is 300 square minus 200 square times 0.020 times 0.5 is 500. 0.025, and then you calculate your force of friction. 500 divided by 0.025 is 20,000 newtons. Now, one thing very important, one thing you must always keep in mind is this, that when you do this type of question, you ask yourself what provides energy and what takes. Jason, thanks for the like. You're amazing physics. I saw some of your videos, and really good job, man. As what I was explaining, for here, your loss in kinetic is 500, force of friction times distance, and you want to calculate the force of friction. Now here, a 1 kg box is pulled up the slope at a constant speed. Now whenever you see this, right, there is no gain or loss. No gain or loss in kinetic. This part very important. Because a lot of students, I find that when they see this type of questions, right, they always think that, oh, there's constant speed, I must factor it in. You must take note that in a question, they always actually give you hints, and you must know how to use the hints. Now, in this question, what you have to do is ask yourself, what provides energy? Ask yourself, what provides energy? There'll be work done by 10 Newton, then your gain in GPE, that will take gain in GPE, plus your work done against friction. Okay, work done against friction. So work done by 10 Newton will be 10 times 50. Mass is 1.0, G is 10, height is 30, plus work done against friction will be force of friction. Actually, you don't even need to do that. Just write work done against friction, because they're not asking you what the friction is. So then I'll take 500, so 300 plus work done against friction. So your work done against friction, you just take the difference, is 500 minus 300 is 200 joules. 200 joules. So as simple as that. So one thing I just want to highlight for those who are here, I thank you for you guys joining us. Just keep in mind there'll be a Kahoot right at the end of this. What we will be doing is that it is important for energy to ask yourself what provides energy, and on the right side you write what takes. So if you get confused, just always apply this framework. Yeah. Now for this question, an object of mass m passes a point x with velocity v and slides up a frictional plane and stops at point y. So straight away you can tell that what is providing energy is your loss in kinetic. Loss in kinetic equals to gain in GPE. Now, for those who are here, right, which one of you can tell me that what about the frictional force? Do I factor that in? For Alicia, for Mark, thanks for all the likes. Thank you, thank you, thank you, guys. So loss in KE equals to gain in GPE. So in this case, right, what will happen is the loss in KE, they tell you that in this object, if your velocity is, let's say, v, so you get this height. So I'll take half m v square equals to mgh, right? So just take note on this. And that means that if you cancel your m, in that case, you'll consider that v square equals to 2gh. So this is the first equation. Now they tell you the same mass passes the point, but now it's twice the velocity. So it'll be half m2v square equals to mgh. So just take note on this. Now what will happen is that if you look at it, actually you can use h equals to v square over 2g. V square over 2g. So h means in terms of v square over 2g. Now if you can cancel your mass, you've got 2 square, which is 4. 4 divided by 2 is 2. So it'll be 2v square over g now. 2v square over g is now the new h. If you look at it, right, the new h, if I express in terms of v square over 2g, isn't it the same as writing? So if let's say I want to get v square over g, right, then what I'll do is I'll take 4 times of v square over 2g. Because 4 over 2 is still 2. And since v square over 2g is h, I take 4h. So answer is C. So it's as simple as that. And that's all you actually need to do for this type of questions. A lot of students, they really complicate this type of questions, and it's not that difficult actually. Now, the engine of a 500 kg car generates a power of 10,000 watt to move the car. Find the time taken to accelerate from a speed of 10 to 20 meters per second. So you have to ask yourself, okay, power equals to energy over time. Now, energy in this case is gain in kinetic energy. Time is what we're trying to get. So gain in kinetic energy is just half bracket 500 20 square minus 10 square over t. The power is 10,000. And you calculate for t. So if I calculate, right, what will happen is 0.5 times 500 times 220 square minus 10 square. Just a minute. You get 75,000. Then you divide by 10,000 and you get 7.5 seconds. And then your answer is C. So it's as simple as that. Honestly, it's not very difficult. Sometimes the question, just apply the formula and then you just start subbing in values. That's all you need to do. Okay. For this, two identical cars move up a slope, different paths. First car takes route XY, route XZ. Both take the same time to reach the destination. Now, the problem with this question is this: they never told you if the friction is being accounted for or not. So that is one part that is going to be a problem. And because you don't know the friction, right? So if you consider a useful power, let's say we talk about useful power. Now, useful power means that what is the energy done used to go upwards. Now, in that case, and also you have to assume something that the kinetic energy is the same. In this case, right, what you have to remember is this: because the height is exactly the same, so what will happen is they tell you two identical cars both take the same time to reach. So in that case, what I can say is power equals to gain in GPE over time. Because the height for both of them is exactly the same, it is the same, time is the same, so power will be the same. So useful power of both cars are the same. Just take note on this part. A skydiver jumps off a plane at point X and first reaches terminal velocity at point Y before he opens his chute, which are following described. So you must remember that as he's falling, there is gravitational potential energy, which is being converted to kinetic. So just take note. But if he's slowly reaching terminal velocity, there will be definitely friction. So I would say that gravitational potential energy to kinetic and thermal, there will definitely be that. Because not all the potential energy is being converted to kinetic. There will be friction. Yeah. So see, a person with the weight W stands on this. This is actually pressure. So this is the next part of pressure. Pressure actually has three formulas: F over A, which is used for solids. Pressure equals to H rho G, height, density, gravitational field strength, and your what do you call your equations lah. So example, like if you have something that is in such a case where you have, let's say, a mercury column. Mercury column is this way, so the weight will be downwards. This is the pressure of gas, pressure of mercury, and this is the pressure of atmosphere. So in this case, right, what you do is pressure of gas equals to pressure of mercury plus pressure of atmosphere. So you're just setting up the framework. That's all you're actually doing. Yeah. So two liquids of different densities were placed. What can be concluded? Now you must remember that here and here, because they're connected by the same liquid, the pressure is the same. So pressure due to X will be equal. So let's say I call this A lah. A. Pressure due to A and pressure due to B will be the same. Now, if you look at the height of this, is a lot bigger than this, which only means because here P equals H rho G, height equals a P over rho G. Now, your height will only be bigger when your density is smaller. So, since the height here is bigger, that only means that liquid X is actually, or liquid Y is denser than liquid X. So, answer is B. Okay, so that's all you just need to do is that you just take P equals to H rho G. Now, two glass containers filled with different liquids are placed next to each other. Point B is a distance. What is the pressure at P different? Why is the pressure at P different from the pressure at Q? Now, because the vertical heights are the same, then by right, the pressure should be the same. But it could be that they have because they have different liquids. When you have different liquids, right, you must remember that your densities are different. So there'll be different density. So that's the reason why the pressure is different. So density of liquid are different. Just take note. A manometer is connected to a gas cylinder to measure gas pressure inside. So always for this type of question, what's very, very important to note is you are looking for the lower point. So here the pressure atmosphere equals to the pressure of mercury plus the pressure of gas. So pressure atmosphere they say is 76. Mercury is going to be 32 minus 25. So your answer is 7. And pressure of gas. So pressure of gas is 76 minus 7 is 69 cmHg. If you want to convert this to actual pressure, I'll just use rho GH. Density is 13,600, G is 10, and height is 69 over 100. Take note that you must convert it to meters. Very, very important. So I'll take 13,600 times 10 times 69 over 100 is 93840. And you round off to 2 sig fig is 94,000. And then your answer is C. Just take note. Yeah. So it's as simple as that. Always look at the lower point. Here, you want to take note is this, that because they are at different levels, right, doesn't mean the pressure is different. The actually pressure is the same. Pressure of P equals the pressure of Q. Now, they say which of the following changes will enable heavier loads to be lifted. Now, in this type of case, right, what you want to do is you want to basically make P as small as possible and Q as big as possible. Because why? Force of P over area P equals the force of Q over area Q. Now, if you look at force of Q, I got area Q over area P times force of P. So if I want the force of Q here to be as big as possible, I want area of Q to be as big and area of P as small as possible. So if let's say you can have diameter of P being halved and this one double, that'll be the best because it's almost 4 times, right? Almost 4 times. Okay. For here, the gas pressure, the mercury in the manometer is replaced with the liquid is less dense. So if you remember, right, pressure equals H rho G, H equals the pressure over rho G. Now, when your density is less dense, it will cause your height to increase. So I would say that it increases. So keep in mind that the difference in mercury will increase when your density drops because it still needs to portray the same amount of pressure. In this question, what you do is you just take F1 over A1. So 2000 equals to F2 over A2. Now for F1 over A1, right, I'll take 2000 over A1, we don't know. F2 is 10,000 over A2. Now I want to get A2 over A1, which is 10,000 over 2000, which is 5 over 1. So answer is D. Right, answer is D. So guys, we are coming to the end of this. We will be going through the Kahoot quiz. So do get your friends, whoever you can get them to join in, and we will start on the Kahoot quiz. Yeah. So let me just prepare that, get that ready, so that you guys can possibly win a Kahoot $10 popular voucher. So let me just start it up, and we can begin. All right. Okay. All right. Let me just start on this. Okay. So the quiz is on. Y'all can start. Okay. Cohen is in. So Cohen, did you have issues just now? I just saw your message. Put it in the chat. Ah, all right. Okay. I'll keep that in mind, Cohen. Okay, Mark is here. So do get your friends to join in. You can share on your Facebook page or just I don't know, is there a link to this? Let me just see, yeah. Is there a link to this Kahoot? Or actually, you can just like take a screenshot and then just send it to your friends, and then you can just get them to sign in. So I'll just give you all about another 3 more minutes. Another 3 more minutes. All right. Okay, I think we've got three of you, and that's how we're going to start. So let's begin. Now, for the first question, Facebook Live Physics WA2 Part 2. And the first question that we'll be talking about is the multi-select. So there are possibility for two options. What causes the stability of an object to be greater? So what do you all think causes the stability of an object to be greater? So okay, I'll give you guys a hint. It has two things that is shown here. It's not three but two. So I'll let you all figure that out and you tell me if you think got the answer. So let's see what you all have done. Okay, so I think most of you mentioned center of gravity, which is true. And the other point is base area. So you must remember that the lower the center of gravity, the more stable the object, and the bigger the base area, the more stable the object. All right, great job. All right, well done, Mark. Lisha, any question? I think Lisha, you forgot about the second point. In a stable equilibrium, where is the center of gravity relative to the pivot? Where is the center of gravity relative to the pivot? So I did mention about this previously about the different placements. So I'll just share with you guys. Definitely, the blue answer is not it. That is one. I'll let you guys figure it out. See the other options. So okay, yeah. So it'll be definitely below the pivot. So just take note that in a stable equilibrium, the center of gravity is below the pivot. Yeah. So y'all just go ahead and try it out. So this is the next question. So which of the following situation has no work done? So is it a ball falls from a tree due to gravity, a saw cuts a piece of wood, a spaceship cruises in space, or a boy drags his bag along the floor? So out of these four options, one of them is it. Now most of you said a ball falls from a tree due to gravity. You need to take note in this type of case, there will be work done, there will be a force and a distance move. So there will be work done. But a spaceship that cruises in space, because there's no constant speed, the resultant force is zero, there is no work done. So that's very important. All right, Lisha. Okay. For Lisha, if you have any questions, please go ahead, put it in the chat. When a person walks up a flight of stairs at constant speed, what energy increases? So yeah, you all go ahead and try this. All right. When a person walks up flight of stairs at constant speed, what energy increases? Now, if you look at the question itself, because it's rising in height, if it's rising in height, what happens is you have gravitational potential energy. But constant speed means that the kinetic energy remains the same. Okay, Lisha, very good. Mom, good job. Now, for the last question, what does a mercury barometer measure? What does the mercury barometer measure? So do you think it's atmospheric, vacuum, water, or gas pressure? So I'll let you guys figure this out. All right. So what does the mercury barometer measure? Definitely will be the atmospheric pressure. So it uses mercury to figure out the pressure of the atmosphere itself. So let's see who are the winners. For third position is Lisha. Very good, Lisha. Mark, okay, Cohen, congratulations, Cohen. So I have your address, Cohen. I will send you the $10 popular voucher by tomorrow latest. Again, keep in mind that next week we will be doing a Facebook Live on the next few topics on chemistry. If I'm not wrong, it'll be mole concept, acids and bases. Now, for those who are here, do put in the comment section if there's any other topics that you want me to do a Facebook Live so I can run through that. So you guys take care, have a great night ahead, and stay safe.